The goal for today is to identify and use congruent angles and the bisector of an angle. Congruent angles, similar to congruent segments, are angles that have the same measure. So, for example, angle ABC is congruent to angle DEF. So let's highlight those in our figure. ABC is here, angle DEF is here. Because the measure of angle ABC is equal to the measure of angle DEF, they are both equal to 65 degrees. Similarly, as we can mark segments congruent by having the same number of little dashes on the line, we can mark angles congruent by having the same number of arcs in the angle. So you can see that these two angles both have two arcs. What that means is that this angle DEA, or DEB you could call it, is the same as angle CBE, or you could call it CBF, because they both have those two arcs to show that they are congruent. So that means that they must have the same measure. An angle bisector, another vocab word, is a ray that divides an angle into two congruent angles. You need to know that the sum of the measures of the smaller angles, so for example, 80 degrees plus 80 degrees, those two smaller angles, angle XYW and angle WYZ, add up to 160 degrees. So that means angle XYZ would measure 160 degrees. So there's a few ways you can say this. Angle XYW is congruent to WYZ. You can see that's marked with the two red arcs. The measure of those angles must be equal, and the measure of the two smaller angles added together equals the measure of angle XYZ, like we said. Let me show you how this will be used in a problem. It says in the figure, ray KJ, that's this ray here, and ray KM, this here, are opposite rays. Ray KN bisects angle JKL. So right when you read that, I would suggest marking these two angles as congruent in your diagram. It says the measure of angle JKN is 8x minus 13, so I'll label that in my figure. JKN is this angle, so label it 8x minus 13. And they also gave us the measure of angle NKL, that's this angle here, is 6x plus 11, so I'll also label this. They would like us to find the measure of angle JKN. That's this angle here. Now we can't just say it's 8x minus 13. That's the expression that represents angle JKN, but it is not its measure. So in order to find its measure, I know that the measure of angle LKN is equal to the measure of angle JKN, since they are congruent. So I can substitute in their values, 6x plus 11, and the expression 8x 13 to represent angle JKN. And then I have an algebra problem to solve. So the first step is subtract 6x on both sides and add 13 on both sides. So I get 24 equals 2x. The next step is to divide both sides by 2. So I get 12 equals x. Once you have the value of x, double check what they were asking you to find. They weren't asking us to find x, they were asking us to find the measure of angle JKN. So I need to go back and substitute in the value of x for the expression. So I have 8 times x, but I know x is 12, minus 13. So I used this, but I plugged in 12 for x. Now I just have to simplify. Remember, you have to multiply 8 times 12 first. That gives you 96. Then I can subtract 13 to get 83. So my final answer, I get the measure of angle JKN is equal to 83. Alright, this practice problem is what I would like you to complete on your own. This one is a tiny bit different, but I think you can do it. Finally, reflect on this question. Explain why these equations are all three acceptable ways to begin solving example 3. That's all I have.